good evening because we are in different stages right now. Okay, so let's talk about a SOTA infrastructure. We talk about a SOTA model or a SOTA inference and so on. So I want to bring to you something about a state of the art infrastructure, and this is very important when you look at tying up the whole generative AI ecosystem because what is happening is that while there is a lot of interest around how generative AI models are deployed, how they are built, and how they are trained. Unless you have like a very good infrastructure, it cannot be taken to the masses. Like, how do you take something from a POC that you have done and successfully established a PMF and take it to scale where a global audience can use your infrastructure is where you need this sort of infrastructure. Now, what are we, right? We are E2E Networks, 15-year-old company, publicly listed, but we are also one of the first AI first cloud providers in India. And what we do is we built infrastructure for so long that we understand how AI works at a very, very fundamental level. And we are able to build this hardware and software hyperconverged stack where we are able to deliver training and inference performance that can help you take your products to the customer. Now, what is being done is completely in India, and these are some things that we have done which are meeting or exceeding benchmarks that have been like provided the world over. In fact, like even exceeding some of the best benchmarks that some of the other companies based in US and etc. have delivered. Now, let's talk about one simple global standard for performance. If you're running GPUs, especially at scale, you talk about H100 or H200s, and if you have an InfiniBand fabric, what is very essential is that you get a library called Nickel that's from NVIDIA. So when you establish this test, this is almost like the first thing that everyone runs when they are running big, large-scale infrastructure. So when you talk about nickel test, so one of the first things that you want to do is to get as close to 400 gigabytes per second, which is not like a very easy feat. So unless you have everything in order, with the right network tune, with the correct kernel loaded, with the options correctly loaded, and all of that, it's very difficult to hit more than 360. That is what many people assume it to be a good number. So what we have done in our test is we recently ran something with 1024 GPU cards, and what we have seen is we are able to achieve around 380 gigabytes per second, which is like very, very good if you look at it comparatively with people who have published these benchmarks. And the other very, very important parameter for this is the model flop utilization. Now, one of the big problems that was existing even in the CPU world and in the GPU world, if you look at the journey of compute itself, how did even cloud come into being is because of the utilization factor, right? Remember when Amazon had this huge infrastructure that they had for their various end of season sales and so on, they figured out that they are sitting on huge amounts of idle infrastructure, right? So that is when they started working on virtualization, and they said that, okay, can we do something about it where we are renting idle capacity that we are not ourselves using and give to customers. So that is when the entire cloud was born. Now, if you look at the per unit economics of a GPU versus a CPU, a GPU, as you might see, it's an order of difference much higher than a typical compute. Now, what you have seen is like you might, if you're following the AI news on any Twitter feed today, you will see multi-billion dollars being poured into infrastructure today. Now, you can't have the luxury of idle CPU cores running that we all assumed it is fairly normal. Everyone said, okay, 10-20% utilization is great on the CPU world. But if you look at the GPU world, what you would have to realize is if you are sitting at 20-30% utilization, every month on a very large cluster, let's say like a 1,000 GPU or a 2,000 GPU cluster, you are serving population scale, you are potentially losing out thousands of dollars every hour, right? It's not even monthly or like yearly. Every hour you are spending more than that. So one of the key optimizations that everyone has to do is to bring this model flop utilization, and the max that NVIDIA themselves have achieved is about 53, 54, and we have also achieved that in the same architecture. So people have written like very very large blog post about achieving like even 50%. We are happily sitting at 54%. And some of our customers, like when they have started training on our infrastructure, they have told us that okay, it's an order of difference whenever they're using any bare metal infrastructure versus using our cloud platform to get this. Now of course, like all of this is very moot if you don't have the enterprise grade efficiency. And enterprise grade efficiency also means that you have things like security, rollback access control, token authentication, and all of those enterprise security controls. If they are not there, then the propensity of any attacks to basically like leave you high and dry is very significant, right? So typically, if I give a case of a single, let's say a simple DDoS attack that comes into your website, what's the max that can happen? The max that can happen is like some pages will be viewed by multiple people. That's it. Whereas in the case of AI, if you have an unauthenticated endpoint and somebody is actually like running like huge amounts of requests into your infrastructure, the fallout of that is it can raise the data center temperature by a few degrees, because these GPU servers are like so much of power guzzling and so on. So there is a huge amount of cost to security and all of that in AI. So which is why you have to ensure that all the enterprise grade efficiency for both training and inference for distributed AI workloads are there. Let's talk about data, because I think one of the key themes that everyone has been speaking yesterday and today is about data. I think the previous talk also referred to what is the data curation, how do you gather data, what is the pipeline that you build for data collection, cleaning up, labeling, and all of that. And storage is very, very essential to an AI use case, because without storage, your GPUs are pretty much sitting idle. Now, what happens is, and you also need storage at scale. It is not just about mounting a file system and saying that okay, I have storage. It is about delivering parallel file systems, right? So parallel file systems are a different construct than your typical file system, because they break the metadata and the access layers into separate cohorts. Now what happens in a parallel file system is you have a metadata server where you can query the location of a file, and you can access these at very blazing speeds. Now, just to give you a sense of the scale, a good performance cluster like a 1024 cluster needs to have each of the GPUs load data at 1 gigabytes per second, right? And the total aggregated throughput for the cluster needs to be around 160 gigabytes per second read and 80 gigabytes per second write. If you're not able to deliver storage at this scale, then typically what happens is your mean factor utilization, if you look at the previous slide, this goes down. And the moment this goes down below like 50, 40 and so on, then you're losing a ton of money. And it's an order of difference. A training that could be completing in, let's say, 12 days may take 18 days or 20 days, right? So that is the order of difference we are talking about. Same thing with an object storage, because we are talking about, if you look at a large language model builder or a foundational builder, you're talking about a petabyte scale storage, right? So unless you are able to load data at gigabytes per second, and that too in an efficient manner, it's not just about the network supporting gigabytes per second. You also need to do an RDMA where you are saving the CPU cycles as well. If you're loading it onto the direct GPU HBM memory, that is when the most performance gains in training happen. And how quickly you are able to load a model, how quickly you are able to load the data, all of this has an actual bearing on performance, which is what we specialize in. And of course, like there are again very very large numbers for object storage. You have to again load it in multiple gigabytes per second to be able to efficiently do training or inference. Now what we have done is like we have packaged all of the things that we have said before into a low code publicly available self-service platform where you can essentially do both training and inference, right? So what do you need in training is a distributed job scheduler like a Slurm or PyTorch Lightning or any of this, plus a bunch of orchestration, plus storage, plus the ability to stitch all together using InfiniBand. And all of this essentially comes up in a couple of minutes, right? If you're launching a 1024 cluster, it can take a few minutes and everything is up ready. All you have to do is just log in into the login node and start your training activity just like that. Whereas if you do it in the traditional manual ways, it can take days altogether just to get this cluster up and running, right? Second thing is inference. That's the next component. Once you have done training, you will obviously go into inference. Now, inference, there is a lot of complexities of running inference at scale, which includes how fast can your tokens be, the TTFT, time to first tokens, and the number of tokens that you can serve in parallel, the number of concurrent connections. All of this has a bearing. Now, tuning all of this manually again requires a huge amount of work. And what we are offering is, we are saying like, you can auto scale inference, it can be synchronous inference, it can be asynchronous inference, and all these modern engines are supported. So let's say you want to run an alternative at scale to, let's say, one of the popular LLM providers like a ChatGPT or a Claude, using Meta, Llama, or any of this. You can run this at scale for your enterprises, for your startups at scale. You can run this, and of course, it's a unified life cycle: train, scale, and then essentially deploy. We have also started working with India AI. Many of you may know about India AI mission. So what we do is, we work with them and we are empaneled with them, where we are providing infrastructure to some of the biggest foundational model providers that have been selected by the government of India. And it's a very strategic partnership, and we have onboarded like a few startups which are part of this. And again, these guys are using essentially the same tech stack in terms of parallel file systems, the training infrastructure, the inference infrastructure, and all of that. And we also work with a lot of startups for solutioning and pre-sales, where we are discovering what use cases and how to essentially take them to scale. Remember, like, there are two very niche skill sets that are coming into the Gen AI space. One is the model builder, and the second one is the model deployer. And these are two equivalent skills that you need to hire. So you may have the best of guy who is working on the transformer model, understands everything, but if he is not able to deploy at scale, then again you have a problem. So that is a unique skill set which we have essentially built into the platform, that any model builder can automatically become a model deployer at scale. And we like work with so many startups, like, and multiple like interesting use cases for these. Again, enterprise scalability and data sovereignty is something that is again very, very critical. So what happens is, like, if your startup is like doing something sensitive for the government or something, and if your data is not within the sovereign location, then you might be risk at not being able to be in full control of your data. So what we are offering is, of course, like a lot of enterprise features, but with essentially saying that the data is in India, governed by Indian laws, and data is handled by an Indian company. That's a very important factor if you get into government or higher education or edtech and all these sensitive spaces. It's very important to own the full stack and not be dependent on something which is not in control of the government of India. Next is, like, we have a very, very strong partnership with NVIDIA. And NVIDIA, apart from being a hardware a player in terms of like building GPUs and so on, they have a much larger software effort where they provide SDKs and operators, and also some of these newer age inference frameworks that they call as NIM. So there's a lot of performance gains and efficiencies when you are bundling any of the open source models as NIMs, or even a proprietary model as NIMs. And they also have a lot of proprietary framework available, like a Riva, which is a speech model. So these are like a well optimized stack, and you can do a one click and deploy them on E2E, and you can leverage all the expertise that NVIDIA does, that they have built over a period of time and they are innovating on, and you can have the best of them on E2E. Now, the next slide is just to give you a heads up on how within the same software, what happens is, like, with the performance improvements through software and hardware infrastructure and the entire deployment, you can get significant amounts of gain through the same hardware. Okay, and this is what I leave you with. It's a complete sovereign class platform, sovereign cloud platform, fully in India, built in India by an Indian player, and our performance is globally benchmarked, and essentially like all the international standards in terms of performance for training, inference, everything is met right here in India. So feel free to talk to us, and we'll be more than happy to connect with each one of you. Thank you.